Hi everyone, I am Rajkumar Pujari. I am a 5th year PhD student at Purdue University. Today I am going to describe our long paper titled Reinforcement Guided Multitask Learning Framework for Low Resource Stereotype Detection. Let us get into the presentation. To begin with, I'll give an overview of the motivation and contributions of our paper. Of late, empirical success of large pre-trained language models have led to them being ubiquitously used in daily life applications that interact with humans. Unsupervised training on huge uncurated datasets is the norm, and this results in harmful text and societal bias creeping into the outputs. This motivates a two-pronged solution. The first is to diagnose and denoise the bias in the pre-trained language models. This is important to remove the bias that creeps into their distributed representations. And the second front is to identify and regulate harmful text externally at the output. This is also required in order to ensure that the future iterations and novel proposals of these language models don't game the debiasing techniques that we develop on the first front. Our work mainly deals with the second front. So in this work, we focus on a specific type of harmful text, that is stereotypical associations in text. Stereotypes differ from other harmful texts such as hate speech, misogyny, abuse, threat, insult, etc. in two important ways. The first manner is that they could also express a positive sentiment towards the target, unlike these other types of harmful text. In this example that we see here, Asians are good at math is a positive stereotype, but it is still undesirable in the society. The second way is that they require the knowledge of their existence in the society to identify them. The example that is shown here, my African American friend loves watermelons, can only be identified as a stereotype if you know the existence of the stereotype between African Americans and watermelons in our society. In this paper, we first devise a focused annotation effort for stereotype detection to construct a fine-grained evaluation dataset. Followed by that, we leverage the existence of several correlated neighboring tasks to propose a reinforcement learning guided multitask framework that identifies and leverages neighboring task data examples that are beneficial for the target task, which is stereotype detection. Now I will go into the details of the dataset. First, I will describe the existing datasets, followed by the annotation procedure, and then the details of our dataset. There are two existing datasets for mitigating stereotypical bias. Both of them are diagnostic in nature, which means they are used to measure the extent of bias in the pre-trained language models. So the first dataset is named Stereotype and the second is named Cross Pairs. Blodgett et al., a recent paper, demonstrated that both these datasets suffer from severe conceptual and operational issues. And in addition to that, diagnostic datasets by their nature also suffer from lack of coverage of subtle manifestations of stereotypes in text, mainly because they are explicitly framed as stereotypes or anti-stereotypes in order to measure the bias of the pre-trained language model. In our annotation approach, because we deal with the second front of identifying the harmful text externally, we address the coverage issue by collecting potential data samples for annotation from two subreddits. The first is r/jokes, which is expected to be stereotype rich, containing a lot of examples of stereotype written text, and the second is r/asks historians, which is expected to be stereotype poor, containing largely factual statements. In order to avoid the operational and conceptual pitfalls of the existing datasets, we stick to Cardwell's definition of stereotypes, which is a fixed overgeneralized belief about a particular group or class of people. According to this definition, we ask the annotators to answer three questions for each sample of text. The first question is that is an oversimplified belief about a type of person intentionally expressed in the text. The second question is that is there an unintentional, widely known stereotypical association present in the text. The third question is that does the sentence seem made up or unlikely to occur in regular discourse. Based on these three questions, we are able to classify the text into one of the three categories. The first is explicit stereotypes, the second is implicit stereotypes and non-stereotypes. We also use anti-stereotypes from the existing datasets. Here are examples for each type of these text shown. The first one reads, Ethiopians like stew. This is an explicit stereotype intended to propagate the stereotype. The second statement reads, the lawyer misrepresented the situation and tricked the person. Although this doesn't explicitly state a stereotype, this still contains the stereotypical association of lawyers being conniving that exists in the society. Hence, this is an implicit stereotype. The third statement reads, Jews spend money lavishly. This is completely opposite to the stereotype that exists in the society, and hence it's called an anti-stereotype. We don't distinguish between explicit and implicit anti-stereotypes in our work. The fourth statement here reads, there is an Asian family that lives down the street. This is a non-stereotype. This doesn't contain any stereotypical association regarding to the group of people. So here are the statistics of the dataset that we collected. This is a small dataset intended to be an evaluation, a focused evaluation set for this task. Now I'll go into the details of the model. First I'll describe neighboring tasks, followed by which I'll describe our multitask learning model, and then our reinforcement learning guided multitask model. Several datasets for harmful language detection identification, such as hate speech detection, offensive language detection, misogyny detection, and toxicity detection, are widely available. These tasks have highly reliable goal data available. They often contain overlapping objectives with the target task of stereotype detection. For example, let us see the two examples here. The first one reads, she may or may not be a Jew, but she is certainly cheap. This is an insult, but this also contains a stereotype of Jews being cheap. The second one is, burn in hell, you Asian bastard. Here we have an abuse followed also including an Asian stereotype. We hypothesize that solving these tasks require understanding largely similar linguistic characteristics of text that we require to understand to solve stereotype detection. Hence, we call these tasks neighbor tasks. In our multitask learning model, we aim to leverage the transfer learning gains from the neighbor tasks to improve the target task. As the tasks have overlapping objectives and largely require understanding similar linguistic characteristics of text, leveraging the intermediate representations from the neighboring tasks should benefit the target task. Based on this intuition, we design a simple hard parameter sharing based multitask learning architecture. Here we can see that the neighboring task and the target task text passes through a pre-trained language model based representation layer, followed by shared intermediate representation layers with task specific classification heads. When we train all these tasks concurrently, we hypothesize that we will observe gains over the target task as opposed to training the target task alone on this architecture. Now let me describe the reinforcement learning guided multitask learning model. The intuition behind this model is that not all examples from the neighboring task are equally useful for the learning the target task. Hence, we train an RL agent on top of the multitask learning model in order to identify those examples from the neighboring tasks which are beneficial for the target task. In the step 1, for each example in the neighbor task, the RL actor makes a select or reject decision. In step 2, the multitask learning model is trained on the selected examples from the neighboring tasks in step 1. In step 3, the RL actor is rewarded based on the change in performance on the target task from before training the selected examples to after training the selected examples. In step 4, we use the loss between the RL agent's actual reward versus the RL critic's expected reward in order to train the RL agent. Now let's look at our experimental setup and results. In our experimental setup, we perform experiments using 6 datasets in 3 phases. In phase 1, we just fine-tune a PLM based classifier. In phase 2, we train the multitask learning model described before for all the datasets. In phase 3, we train RL guided multitask learning model for each task as target task. We experiment with 4 pre-trained language models as base classifiers, namely BERT base, BERT large, BART large, and excellent large. We use the following 6 datasets for our experiments: hate speech detection, offensive language detection, misogyny detection, coarse-grained stereotype detection, which is a combination of stereoset and cross-pairs datasets, and then we have a fine-grained stereotype detection, which is the dataset that we annotated in our work, and 6 is jigsaw toxicity dataset, which is only used for training, not for evaluation. Now let's look at the results on the 5 tasks that we have evaluated on. And we see that the best model on each of the tasks is a reinforcement learning guided multitask learning model. And we also observe consistent gains from base classifier to multitask learning and then followed by multitask learning to RL guided multitask learning framework. So these gains support our hypothesis that we can leverage neighboring tasks to improve the target task, and on top of that we can use intelligent selection of examples to further improve the performance on the target tasks. Now let us look at few ablation studies. In the first ablation study, we study the impact of the MTL prior on the reinforcement learning guided MTL model. In our experiments, we initialize the parameters of the RL guided MTL model with trained parameters from MTL multitask learning model. In this ablation, we initialize the RL MTL model randomly and observe the difference in the performance. Here in this table, we show the results. We see that there is a consistent drop across all the target tasks when compared to the MTL initialized RL model versus the random initialized RL model. We see that the drop is more significant in coarse grain stereotype detection and fine grain stereotype detection as opposed to the other tasks. This shows the importance of training the. This shows the importance of starting the RL guided model with an MTL prior. Now let us look at the second evaluation study called neighbor task impact. In this evaluation study, we study the impact of each neighbor task with each task as target task. Here we see that for each task as target task, we select one neighboring task and see its impact and compare which task is most useful for the target task. Here, it is interesting to note that the coarse grain stereotype detection data doesn't contribute significantly to the performance of improvement on fine grain stereotype detection data task as it could be expected. Rather, we see that a hate speech detection task has the most impact, followed by offense detection task. This might be due to the presence of anti-stereotypes and several operational and conceptual issues as pointed out in Broadgate et al. Hence, we see the importance of having a high quality reliable goal data on the tasks. So to conclude, we tackle the problem of stereotype detection from data annotation and low resource computational framework perspectives. We devise a focused annotation task in conjunction with selective data candidate collection to create a fine-grained evaluation set for the task. And then we utilize the neighbor tasks with abundance of high quality goal data in our multitask learning model. We further propose an RL guided multitask learning model that learns to select examples from the neighbor tasks which benefit the target task. Thank you for listening. Feel free to reach out with any questions.